In this video, we're going to talk about random variables and probability density functions, aka PDFs. First of all, what is a random variable? How's that different from a regular variable? A regular variable, x, might be something that has a specific unknown value that you're trying to solve for, like in an equation or something. But if x is a random variable, that means it could take on a number of different values with different probabilities or likelihoods. So for example, if x is, say, income, it's not that everyone has the same income that you're trying to solve for, but rather different people could have different incomes, and different incomes might be different likelihoods. Some incomes might be more common than others, and so that's what we'd capture in a random variable, the values and the likelihoods. Let's take a look at an example and see how this might work. Let's say we know that 50% of all master's students take 3 classes, another 30% take 2 classes, 10% take 1 class, and another 10% take 4 classes. So we're given all this information, and let's say we're asked, what is P of x equals 5? So let's talk a little bit about this notation over here. This P is referring to the probability of the thing inside the parentheses. The thing inside the parentheses is saying that x equals 5, where x is the number of classes taken by a master's student. So if x is defined as the number of classes that you're taking, and the question is, what is the probability of a randomly selected master's students taking 5 classes? Well, it might seem like there's not enough information here because we're only given information, let's see, about taking 3 classes, 2 classes, 1 class, and 4 class. But if you think about what these probabilities add up to, 50% plus 30%, that's 80, plus another 10, that's 90, plus another 10. So these already add up to 100%. So this already captures everybody, which means that nobody is taking 5 classes. So this tells us that the probability that a randomly selected master's student taking 5 classes is in fact 0. So what if we were asked, what's the P of x equals 1? What this means is it's asking us for the probability that a randomly selected master's student is taking 1 class. And so we know that 10% of all master's students are taking 1 class. So if we pick a master's student at random, there's a 10% chance that they're one of these people who are taking just 1 class. So there's a 10% chance. And the way to write 10% as a probability, meaning a number between 0 and 1, is to move the decimal place over by 2. Here's why that works. 10% is basically saying 10 times 0.01. This percent symbol is actually a number, and that number is 0.01, so 10% mathematically is the same thing as the number 10 times 0.01, which is 0.10. If you move the decimal in 10 over by 2, it becomes 0.10. And so here we would say that there's a 0.1 probability that a randomly selected master's student is taking exactly 1 class. If we were asked for what's P of x equals 3, well, we know 50%, half of all master's students are taking 3 classes. So if we pick a master's student at random and we're wondering what's the probability that they're taking 3 classes, it would be 50%, which simplifies to the probability 0.50, aka, again, 50%, but moving the decimal place over by 2 gets us that there's a 0.5 probability. Now, let's take stock of all this together. If we were to just try to organize all the possible values of x, how many classes you're taking, it looks like people could either take 1, 2, 3, or 4 classes. Nobody's taking 5 or more. Nobody's taking 0 classes. So if these are all the possible x values, we could make a little table describing the probability of each of those outcomes. So again, let's take stock big picture. X is a random variable here, and what that means is it could take on a number of different values, and those different values have different likelihoods associated with them. They're all not necessarily equally likely. And so whenever we do this, whenever we represent all possible values of x along with all of their likelihoods, that is called a PDF, probability density function. So one way to represent a PDF is a table like this. let's just fill out this table to see what it would be. We kind of already said here that the probability of taking exactly one class is 0.10. The probability of taking two classes, according to this information we were given, we know 30% take two classes, so that probability is 0.30. We know 50% take three classes, so that probability is 0.50. And we know 10% take four classes, so that's 0.10. Notice that all these probabilities need to add up to 100%, aka the number 1. That's what they must add up to. If they don't add up to 100%, then that's not a valid PDF. Also, these probabilities can't be negative numbers. Those are the two sort of rules. Is you can't have negative probabilities, and all possible values need to add up to 100% likelihood. That's how you know you've captured the entire distribution. Now, a table isn't the only way you can represent a PDF. You can also represent a PDF graphically. So here, if we had the random variable x on the x-axis, the y-axis would then have the probability of that specific value. So here, the random variable x could either be 1, 2, 3, or 4, and the different likelihoods, let's see, there's a 10% probability of being 1, of x being 1, taking one class. There's a 30% or 0.3 probability of two classes. There's a 0.50, that's the highest bar here, of taking three classes, and another 0.1 probability of taking four classes. So this this graph over here, in this case it looks like a bar chart, is also an equally valid representation of the PDF here. Now, there's also a third way that you can represent a PDF, and that's with an equation. Sometimes whenever it's like very systematic, you can actually have an equation. Sometimes those equations are complicated. In this case, there's not much of a pattern to it, so if we did want to write an equation, here's what that would look like. It would basically be a piecewise function. So it would look something like this. P of, and this is new notation to pay attention to, the probability of x equaling, so this is the common notation is capital X is the random variable, so just like before, this is a capital X over here. And you know how here we had x equaling 5 or 1 or a specific value? So a placeholder for any specific instance of it is lowercase x. With x, it's a little bit harder to tell the difference sometimes between capital and lowercase, but you know, if you have capital Y equals lowercase y, it's confusing for people the first time they see that. But essentially here we have the probability of x equaling a specific value of x is, and then that's where the probabilities are either 0.1, so the probability of x equaling a specific x value is 10% if that lowercase x was 1. So this is just us taking the first row in the table and saying if we wanted to put that into this equation, the probability of x equaling, and this lowercase x being 1, is 0.10. So that's all that's saying. That's how to read a piecewise function. And again, if you've already seen how it works here and here, it's not super crucial to be a master at all of these, but again, it's just important to know that there's more than one way to write a PDF. So here you would just write it like this. So this would essentially be the piecewise function representation of the PDF. Now, when we talk about continuous distributions in the next video, we'll see that sometimes this you can't really have a table with a continuous one, so that's where we're going to see that you can either have a graph that's going to maybe look a little bit more smooth. That's where you'll see something like a normal distribution, which you might have seen before. This PDF is also a type of that.